Hi guys, welcome to this lesson. So in the previous lesson, we looked at testing after development. So here we want to look at monitoring AI agent in production. So essential strategy for reliability and continuous improvement of deployed agents. So this is very, very important for measuring the reliability of the system. The first one we did was performance. So you test to determine the performance and you measure to collect metrics. So for performance efficiency, that is in line with the well architected framework for CAF. So here we want to look at monitoring. So monitoring AI agent in production. So the first slide says importance of monitoring in production. So monitoring acts as the nervous system of deployed agent, AI agent, okay? So detect failure early, identify performance regression, understand real world behavior, and also improve the system continuously. So monitoring as a learning feedback loop. So monitoring allow you to get feedback from the behavior of the agent, from the operation of the agent, from the working of the agent, from how the system or interact together, interact with the business application, and whether it is perfectly designed or architected. So in monitoring, you will see what is failing, where the agent is failing, what is successful, which behaviors are successful. You see production traces, which have improved evaluation data set. So monitoring also help to distinguish real failure from variation. So in monitoring, you can check for criteria, you can test monitoring help us to check for criteria, test consistency, measure variance, and detect anomalies. So from monitoring or collecting data from monitoring, you can detect anomalies or data drifts in the system. You can measure variance, how the system change based on implementation or operation, or you can test for consistency, which is reproducible, rerun, or multiple time, and check criteria, whether output meets success criteria. Type of metric. We have infrastructure and workflow. So what kind of metric can you collect at specific level? So for CPU and memory level, you can measure system health through throughput and memory usage. So service uptime, track the overall availability and service uptime. So you can check, you can monitor request latency, where you monitor request latency with by defining P50, P95, and P99 percentage. So at CPU level, so you can measure service uptime, memory and CPU usage, and request latency. So you can also measure task success rates, to-core health, and retry fallback loop. So types of metric: quality and user feedback. So under quality and user feedback, you can monitor hallucination rates, prompt and token efficiency, embedding drifts, query rephrasing, task abandonment, and user rating and feedback. So these are what you can monitor under quality and feedback. Then for open source monitoring tag, of course, in software engineering, we have this open source monitoring stacks. We have open telemetry, which is used for which is used to instrument application and collect telemetry data. So you can use open telemetry to collect data. You can use Loki for aggregation and search system. You can use Tempo for distributed tracing and backend. You can use Grafana for visualization, dashboard, and alerting system. So if you are deploying to cloud, for example, deploying to Azure, you can use Azure Application Insight or Azure Monitor to collect all this metric and then use visualize everything in dashboard, or use log analytic log or workspace to analyze everything using KQL in real time. Then you can use application insight or Power BI to visualize as well. So monitoring platform. So just as we have said earlier, monitoring platform are Grafana and Loki, which are flexible, open source, highly customizable, slightly complex to manage. We have ELK Start, which is this is elastic search. Okay, powerful log analytic and search, high resources usage. We have Arise Phoenix, which focus on LLM evaluation and debugging. We have Signals, which is a unified platform for log metric and traces. We have Landfills, which is designed specifically for LLM and agent observability. So instrumentation with OpenTelemetry. So how do you set up OpenTelemetry? So instrumentation means embedding telemetry directly into agent code. So remember, these observability tools must also be designed from beginning into your architecture. It is not an afterthought. Must be designed from the beginning into the system. Here, so you can do execution start and end. Define that. You can define tool usage, token. You can collect metric on tool usage, token consumption, latency, and success or failure rate. Then visualization and alerting. Of course, Grafana is there for that. Grafana provide dashboard that visualize monitoring data and notify teams of issues. So token usage. Grafana can visualize token usage, tool latency, task success. Can also visualize hallucination rates, where you know whether it is high or low, increase retries, and slow to response. So monitoring deployment strategies. How do you deploy your monitoring tools? So shadow mode, you can use shadow mode where you run a new agent alongside the current one without exposing it to user from behavior comparison. You can use canary deployment where you release the new version to a small percentage of users, to a small percentage of users first before rolling out the whole one. Then you can use regression trace where production failure are converted into automated test cases. And then you can also use self-healing agent where agent automatically recover using fallback strategies when failure occur. So using user feedback for monitoring. So user behavior provides important signal that can be integrated into monitoring dashboard. So you can use user feedback also for monitoring. You are designing for people, so you should also collect feedback to them to monitor the system. So you can use their rephrase queries, abandon task, explicit rating to also monitor the reliability of the system. So detecting distribution shift over time, user input and environment change, which can degrade agent performance. So we have called Mongorov's Smirnov test. You can use it to test distribution shift. You can use a callback labeler divergence principle to also test. And you can use population stability also to detect distribution shifts. Cross-functional metric ownership. So we have stakeholder and the metric they own. So product teams own user feedback and task abandonment metrics. We have machine learning engineers. They own hallucination rates and embedding drifts because they design the foundation model. So hallucination rate and embedded drift is their business and they have to resolve it. Infrastructure and site reliability engineers. So these people owns latency, token cost, and system uptime. So key takeaway, effective monitoring transform raw telemetry into actionable insights. So always make sure you implement continuous observability, structured telemetry collection, real-time dashboard and alert is set up. You can use Power BI for real-time dashboard, or you can use Grafana as well. Production feedback loops must be ensured, and cross-team collaboration is very, very important and must be set up. So thanks guys, this is the end of this lesson. Please do well to subscribe and like the channel. See you in the next video. Bye.